Okay, so today we'll be doing algebraic long division. It's very closely related to the numeric division that we already do. सबसे पहले let's start with proper fractions and improper fraction. When I talk about the numeric division, what is a proper fraction for you? पहले तो मुझे ये बात बताओ. What is a proper fraction? The numerator has to be smaller than the denominator, so that is a proper fraction. For example, 7 upon 9. 2 upon 3, 5 over 12, 8 over 14, yeah, 15, let's see. So all of these are proper fractions when the numerator is lesser than the denominator. This is for numeric division. Now, what about algebraic proper fraction? For that, we must understand what is order of a polynomial. We have already studied polynomials, but I'll just revise it. In which when we have studied binomial as well. Binomial is when we have two unlike terms. Polynomial is when we have more than two unlike terms. And specifically polynomial of x, if I am calling it. So for example, I am calling this a polynomial of x, x power 4 plus 4x cube plus 2x minus 7. Now, what is order of a polynomial? Order is the maximum power of the variable that is in the polynomial. That is called order of the polynomial. So what is the order of this polynomial? Order is 4. So order is the maximum power of the variable in a particular polynomial. That is what is called order of the polynomial. So how do we get a proper fraction? Okay. When we have poly means many, nomial means terms. When we have multiple unlike terms, that means the terms that we cannot add or subtract, that is what we call polynomial. Numerator and the denominator. Okay. So now what do we call a proper algebraic fraction? When the order of the numerator is lesser than the order of the denominator. That is what we call a proper fraction. Four x cube plus 2x minus 7. So what is a proper algebraic fraction? When the order of the numerator is lesser than the order of the denominator. That means the maximum power in the numerator has to be lesser than the maximum power in the denominator. This is what we call a proper fraction. Generally, if I do not consider decimal values, I cannot further divide proper fractions. Is that right? Similarly, in this one as well, we will only be dividing improper fractions. Again, I'll take two examples. One example of the numeric value and the other. If I want to divide 9, 8, 1, 7 by 3. How do I start? Okay, let's change the number by 5. How do I divide this by 5? Do I consider the entire number and I start dividing? I am only focused on this 5 and the first digit, whether it's divisible or whether it's greater than or equal to 5 or not. And then I say, okay, 5 ones are 5. Is that right? And then I subtract them. And what remains is the number 4. And then I carry on the 8 and everything. Obviously, we'll be following a very similar pattern with the algebraic division as well. So right now, if I tell you x to the power 4 plus 3x cubed minus 4x squared minus 5x plus 1 has to be this polynomial has to be divided by x plus 1. This is a division. First of all, you must see that if I make a fraction out of it, will it be a proper fraction? No, it will not be a proper fraction. It will be an improper fraction. Hence, it's divisible. So we'll try to divide this, and obviously we'll be following all the patterns that we have already done with the numeric long division. Nothing new. But we will just be careful with the steps and the things that we will write. So I will write here x to the power 4 plus 3x cube minus 4x squared minus 5x plus 1. And remember, this has to be divided by x plus 1. Just like the numeric one, we were not focusing on the entire number. We were just keeping in focus 5 and the first digit. Similarly, in the algebraic one as well, we will not focus on the entire thing. We will only focus on the highest powers of the variable. What will we focus on? The highest power of the variable. Let's see this. I will only focus on this x and this x. What do I need to multiply this particular x with to make it x to the power 4? How do I make this x to the power 4? I'll repeat some terms for you as well. What is this called? This is called divisor. This is called divisor. So what do I need to multiply the divisor with in order to make it x to the power 4? If it is confusing for you, you can divide it separately as well. If I take x to the power 4 and I divide it by x, so I figure out I must multiply it with x cube. If I just multiply it with x cube, will this become x to the power 4? So I must multiply this by x cube. Achha, what do I do? How do I write this 5 over here? Basically, 1 is the quotient. 1 multiplies by 5 and I get a 5 over here. 5 ones are 5. The same thing will be done with the algebraic one. This x cube, which is the quotient, it will multiply by the entire divisor. And what will I get? Very good, x4 plus x cube. Is that right? Now after this, what operation do we perform? We subtract. Is that right? We'll be doing the exact same thing over here as well. We'll subtract this. We already knew this would have cancelled out. 3x cube minus x cube. What will I be left with? 3x cube minus x cube, 2x cube. Is this clear? Now, whatever is left off will be carried on minus 4x squared. Again, I am focused only on the highest powers. Now, x and this 2x cube is the highest power of x. इसको किससे multiply करूं? What do I multiply this x with to make it 2x cube? Again, if it is confusing, you can simply divide 2x cube by x, 2x cube upon x, 2x square. Sign is also very important. I will put that in the quotient, 2x squared. But again, 2x square will multiply with the entire divisor, and I'll get this as 2x cube plus, very good, 2x square. And then what do? We subtract. Is that right? We are doing everything that we were already doing in the numeric division, but we are only keeping the operations into focus. This 2x cube and 2x cube cancelled out. Now remember, this is minus 4x squared, and this will become minus 2x squared. So minus 4x squared minus 2x squared will become minus 6x squared. And the next term will be carried on. I'll clarify. Don't worry. Again, focus on the highest powers of x and minus 6x squared. What do I multiply this x with in order to make it minus 6x squared? Very good. Minus 6. I told you sign is important. And when you multiply it with minus 6x, you get minus 6x squared and minus 6x. And you subtract both of them. When you subtract, minus 6x squared gets cancelled out. Remember, this is minus 5x and this will become plus 6x. So what will you end up with? Plus x and plus 1. So now I only need to multiply it by plus 1. And this will become x plus 1. Will I be left with any remainder? I'll subtract it. Very good. This will be cancelled out. And 0 will be my remainder. So another thing I can say after looking at the remainder is that x plus 1 is a factor of the polynomial. X plus 1 is a factor of the polynomial. A factor is a number that completely divides into another number. Is that right? Like 10 is 2 is a factor of 10, 5 is a factor of 10. So x plus 1 is a factor of the polynomial. Is this clear? Okay, bache, isme the question says find the quotient and the remainder when this polynomial 6x to the power 4 plus x cube minus x square plus 5x minus 6 is divided by this entire thing. It's a past paper question. So I told you the focus will not change. Focus is still on the highest powers of x. So it is 6x to the power 4 plus x cube minus x squared plus 5x minus 6. And this will be divided by, the divisor is x square minus x. Again, we'll only focus on the highest powers of x. So what do I multiply the 2x square with to make it 6x to the power 4? I've told you if you are having trouble with this, you divide it. You take 6x to the power 4 and you divide it by 2x squared, and you will understand what do you need to multiply the divisor with. So 2x cancelled out, 3x squared, 3x. But again, the quotient will multiply by the entire divisor. 2x square minus x plus 1 is one single divisor. Is that right? So yeah, we are focusing on the highest powers, but we'll ultimately divide it by the entire divisor. And what will we be left with? 6x to the power 4. 3x square will multiply with minus x as well. This will become minus 3x cube. Signs are very important in this one. Plus x will multiply with 3x square, it will become plus 3x. And then we will subtract them. What did we discuss? This 3x square will multiply by the entire divisor, right? Multiplied with 2x square, it became 6x to the power 4. Multiplied with minus x, it became minus 3x. The same 3x square multiplied with plus 1 became 3x squared. And when I subtract it, this will cancel out. Plus x cube, again, this minus and minus will become plus, and this will end up becoming 4x cube. Minus x squared and minus 3x squared, this will be minus 4x. Again, I'll carry forward another term from the top. What do I need to multiply it with now? 2x square in order to make it 4x cube. Now this is my focus. How do I make this 2x square a 4x cube? I'll multiply it with plus. Well done. The sign is important, plus 2x. Now the quotient will multiply by the entire divisor, and this will become 4x. 4x cube minus 2x squared and plus 2x. And then what will we do? We will subtract. I know this will cancel out. Minus 4x squared, and this will become minus and minus plus. This will become minus 2x. Plus 5x and minus 2x will give me plus 3x. And then I'll carry down the minus 6. Again, can I divide this 2x square by minus 2x square by 2x square? Yes, I can. I'll multiply it by minus 1. And this will become minus 2x squared minus, this will become plus x. This will become minus 1. Sorry, it will be minus 2x squared. When we'll subtract, this entire thing will be cancelled out. The x squared term plus 3x minus x is 2x minus 6, and plus 1 will give me minus 5. So the question is asking me the remainder and the quotient. The quotient is 3x squared plus 2x minus 1. Well done. The remainder is 2x minus 5. One thing to observe is that when my divisor is x square, it can divide terms up to x square, but not a power less than it. So yeah, the power becomes less than 2, it cannot further divide it. Now this becomes a proper fraction, right? So that is why I told you initially what is a proper fraction. Is this clear? Another past paper question in which 2x cube minus x squared plus 6x plus 3. This polynomial is supposed to be divided by x squared plus 3. Now, what do you see? Is there any term that is missing in this? If you ever get such a polynomial or the divisor in which one of the terms from the middle is missing, you must do this to reduce your chance of error. Observe. What will I do? I'll write x squared plus 0x plus 3. Why have I written a 0x? You'll understand this. In order to fill up the term, because I did not have the x containing term. And what error would have that led to? You have already attempted it and you have figured it out. It is causing you an error and you're not getting all the x in descending order. Is that right? This will reduce your error. इससे multiply करें इसको again, focusing on the highest powers only. I must multiply this by 2x. And this will become 2x cube plus 0x. 0 multiplied by anything will be 0x squared and plus 6x. Is that right? And I'll subtract both of them. So now what did this do? This made sure that below x cube is the x cube term, below x square is the x square term, even if it is a 0x squared. So it made this subtraction easier. 2x cube cancelled out. This will be minus x squared. 6x also cancelled out, but do write it as plus 0x plus 3. So now I must multiply it by minus 1. And this will become minus x squared plus 0x and minus 3. So I'll subtract both of them. X squared cancelled out. There was no term of x. And then plus 3 will become plus 6. So my remainder is, first I write my quotient is 2x minus 1. And the remainder is 6. Is this clear now? So if you ever get such a question, which one of the terms from the middle is missing, either in the polynomial, which is called the dividend, or in the divisor, you always write it with a 0 coefficient to help you reduce your own error. Is this clear? Okay, so again we need to divide this. Zara gaur se have a look at this. I told you whether the divisor or the dividend, if they have any term missing, you write them with a 0 coefficient to reduce your chance of error. Now I will write plus 0x cube plus 0x squared plus 0x plus 1. And in this one, I don't need to add anything. X squared minus x plus 2. Again, focusing on only the highest powers. What do I multiply x squared with to make it 2x to the power 4? 2x squared. But the quotient will multiply by the entire divisor. Is that right? So multiply 2x squared with it. You get 2x to the power 4 minus 2x cube and plus 4x squared. And now when you subtract them, this will cancel out. 2x squared multiplied with 2, you get 4x squared. This will become 2x cube positive because minus 2x cube and minus, and this will become minus 4x squared. Want, you can write a plus 0x. Again, I'll multiply it with plus 2x, focusing on the highest powers only. So this will become 2x cubed minus 2x squared plus 4x. I'll subtract them. This will be cancelled off. This will become minus 2x squared because minus 4x squared, and this will become plus 2x squared and then minus 4x. And I'll carry down the plus 1. Then I'll multiply it with minus 2. This will become minus 2x squared plus 2x and minus 4. I'll subtract this. This will be cancelled off. Minus 4x minus 2x will become minus 6x plus 1, and this will become plus 4 plus 5. So I'll say that the quotient is 2x square plus 2x minus 2, and the remainder is minus 6x plus 5 or 5 minus 6 has both mean the same thing. Is this clear?